are updated every year. And I would point out to teachers and students, if there are any, that MIT has its open courseware. And this is a big resource. So we don't need to reinvent this wheel. This open courseware almost at undergrad and grad students in every area of engineering and social sciences. Complete lectures are available in PDF form, in a recorded form, and freely every teacher and student can use. So I very frequently use this material for teaching at undergraduate level particularly. I can supplement with other materials, but it's, I think, excellent work that MIT has done, and this is available under OCW at MIT, Open Courseware, right? Second question, what you say as far as the terrain survey is concerned, I would suggest that your own engineers could do it better as far as just advisory services are concerned or partly projects are concerned that we could undertake together. And that is what I said, collaboration. We could send you some technical reports of similar projects that have been done in Pakistan. You can benefit from that. Or our experts, we can send you our master's or PhD students shortly for some time, and you can discuss, and they could be beneficial. Your collaboration would be definitely welcome in the area of wireless communication.
Any other questions? No. Thank you very much, Professor Khan.
Thank you.
طبعا في الختام أتوجه بالشكر الجزيل لكافة الحضور الكرام على حسن الإصغاء وعلى المداخلات القيمة، واعتذاري لمن لم تتح له الفرصة في المداخلة لأسباب خارجة عن إرادتنا وهي ضيق الوقت. ولكن أحب أن أذكر أن أحد أهداف هذه الندوة هو إتاحة الفرصة للباحثين والمهتمين العمانيين بالتواصل مع الزملاء أساتذة كراسي مولانا حضرة صاحب الجلالة لبدء دراسات وبحوث مشتركة ستعود بالفائدة على الجميع. لذلك نشجع كافة الحاضرين ومن لم يحضر أيضا ويقرأ عن الندوة بالتواصل خلال القنوات المعروفة مع الباحثين. ومما يثلج الصدر أن المداخلات تبين الاهتمام الواسع من الشباب والشابات بأمور علمية وأمور تتعلق بالثقافة العامة أيضا. اسمحوا لي أيضا أن أتقدم بالشكر الجزيل لمعالي الدكتورة راوية وزيرة التعليم العالي وكافة العاملين في وزارة التعليم العالي وجامعة السلطان قابوس على الإعداد الجيد لهذه الندوة القيمة. ولا يفوتني أن أشكر كافة الأساتذة الزائرين على محاضراتهم وأوراقهم القيمة، ونتمنى لهم إقامة سعيدة في السلطنة ورحلة موفقة عند عودتهم إلى بلدانهم. وفي الأخير وليس آخر، أتوجه بالشكل الجزيل لسعادة الأخ الدكتور هلال الهنائي أمين عام مجلس البحث العلمي على صبره وعلى يعني هو عنده كثير مداخلات لكن سكتناه، على صبره وعلى إدارته معي لهذه الجلسة. شكرا لكم جميعا والسلام عليكم ورحمة الله وبركاته. شكرا. دكتور ياسر، هذا للبيع ولا بتاخذهم معك؟
نرحب بكم في الجلسة الثالثة والأخيرة من ندوة كراسي جلالة السلطان قابوس بن سعيد المعظم العلمية وإسهاماتها في تنمية المعرفة الإنسانية، حيث ستحتوي هذه الجلسة على 4 أوراق. الورقة الأولى بعنوان إدارة المياه في المناطق شبه القاحلة، هل الكوب نصف ممتلئ أم نصف فارغ؟ ثم الورقة الثانية بعنوان إمكانات إنتاج علف الشعير باستخدام نظام الزراعة المائية في دول مجلس التعاون الخليجي اعتمادا على مياه الصرف الصحي المعالجة. ثم الورقة الرابعة الثالثة ستكون بعنوان إلكترونيات أشباه الموصلات ذات الفجوة الحزمية العريضة واستعمالاتها في التطبيقات ذات الطاقة العالية والحرارة المرتفعة. ثم الورقة الرابعة والأخيرة لهذا اليوم ستكون حول وحدة الدراسات العمانية ودورها في إثراء الدراسات الشرقية في عمان. اسمحوا لي ضيوفنا الأعزاء أن ندعو معالي شريفة بن خلفان اليحيائية الموقرة وزيرة التنمية الاجتماعية لترأس هذه الجلسة، وسيكون مقرر الجلسة سعادة الدكتور حمد بن سعيد العوفي وكيل وزارة الثروة السمكية. متابعة طيبة.
بسم الله الرحمن الرحيم، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه وسلم. سعادة الدكتور علي بن سعود البيماني رئيس جامعة السلطان قابوس، أصحاب السعادة المحترمين، أساتذة الكراسي البحثية الأجلاء، أبنائي طلبة وطالبات جامعة السلطان قابوس والجامعات والكليات في السلطنة، الحضور الكريم، السلام عليكم ورحمة الله وبركاته. فإنه ليسعدني أن أتشرف برئاسة الجلسة الثالثة من جلسات هذه الندوة التي خصصت لعرض بعض إسهامات كراسي صاحب الجلالة السلطان قابوس بن سعيد المعظم العلمية وتبيان إسهاماتها الكبيرة في إثراء ساحات العلم عبر العديد من حقوله ومجالاته، وفي تنمية العلوم والمعارف الإنسانية. تأتي هذه الندوة بهدف تحقيق المزيد من الإثراء لأدوار وأهداف هذه الكراسي العلمية التي لا شك في أن تواجد منظومتها في أفضل وأميز جامعات العالم عبر العديد من قاراته يمثل جزءاً من إسهامات سلطنة عمان الحضارية ودورها في ثراء التواصل الثقافي والحوار بين الحضارات وتعزيز أواصر الصداقة والوئام والسلم بين الأمم. الحضور الكريم، لقد خصصت جلستنا الثالثة لهذه لمحور العلوم التطبيقية والموارد البشرية، وربما كان أبسط تعريف للعلوم التطبيقية هو أنها تلك العلوم التي تهدف إلى استثمار وتطبيق مختلف المعارف العلمية، سواء تلك التي أفرزتها العلوم الأساسية أو العلوم الطبيعية، في حل مشكلات واقعية معاشة. وعليه فإن البحث التطبيقي هو كل بحث صمم لحل مشكلات عملية وواقعية في عالمنا الحديث، وغني عن القول بأن توظيف العلم والمعارف لحل مشكلات الإنسان وإثراء حياته يمثل تطوراً وانتقالاً من مرحلة العلم للعلم فقط إلى مرحلة العلم لتحسين حياة الإنسان والارتقاء بها. ولعلي لا أضيف جديداً إذا ما ذكرت أن التقدم والرقي في عالمنا اليوم يعتمد اعتماداً أساسياً على تطبيقات العلوم والتكنولوجيا التي أصبحت بلا شك من أساسيات الارتقاء والنمو الاقتصادي التي لا يمكن إهمالها أو الاستغناء عنها. الحضور الكريم، يشرفنا جميعاً اليوم الاستماع إلى 4 من الأساتذة الأجلاء، ووفقاً لما جرى عليه نظام هذه الندوة فسيسمح كل من الأساتذة الأجلاء 45 دقيقة لتقديم ورقته، وتعقبها 15 دقيقة للمناقشة. نبدأ الآن بالورقة الأولى، وهي البروفيسور رود شوتينغ، أستاذ كرسي السلطان قابوس للإدارة الكمية للمياه بقسم علوم الأرض بأكاديمية روزفلت بجامعة أترخت بهولندا، وله العديد من البحوث والمشاركات في مجموعة من المشاريع الوطنية والدولية المرتبطة بإدارة المياه، كما وقد حصل على عدة جوائز علمية وأكاديمية. ورقته ستكون بعنوان إدارة المياه في المناطق شبه الجافة، هل الكوب نصفه ممتلئ أم نصفه فارغ؟ فليتفضل.
Thank you very much.
Thanks.
Excellent.
بيعطوهم.
works. Does it work? Not too loud, please. Not too. Is it okay? Good morning. Is it okay now? Yeah, I think it's going to work. I thank the Ministry of Education for arranging this event. Of the world. It is not working, I'm afraid. Am I right? Yeah. I would like to talk about water management in semi-arid regions, and my question is the glass actually half full or half empty? What I would like to do in this presentation is, first of all, give you an idea of what actually water management is, because I don't think many people in the audience do really know what we do in water management. Secondly, I would like to look at 4 really huge projects in the world related to water management, and these projects have, on the one hand, very good results, but on the other hand, they also have very bad side effects, and I would like to talk about that. Moreover, I would like to talk about water availability and water management in semi-arid regions and come up with some conclusions. Now, I hope this is also working. No, it isn't. So I do it manually. Nothing works. I'm very sorry. So maybe in the meantime, I would like to inform you about the background of my chair. It's the Sultan Qaboos Chair of Quantitative Water Management. So maybe I take this one. It's better. Yeah, I'm very sorry. Responsible for this. I'm responsible for the water management. So in 2005, actually, our prime. Hello. Yeah. Okay. So in
this.
Will change.
Cannot.
Okay, 1, 2. So I'm going to start where I left. In 2005, our Prime Minister Balkenende visited Oman, and actually several companies in the Netherlands raised funds for a chair in quantitative water management. And in 2005, this chair was basically presented to His Majesty. In 2007, they started looking for a candidate, and according to the academic rules, the very strict rules, a search committee was constructed, and they at some point found me. So I'm really extremely happy to occupy this chair. Now, whenever this works, we're really going to start with the presentation. It is.
We have a flash for the presentation because when we turn off, we will lose it. We have the main presentation.
Yeah. So, in the meantime, maybe I can say something about my chair. So, what I think is extremely interesting about having this chair is that I come from a country which is really a wet country. It's a country that for almost 30% is below sea level. So that implies that we have a lot of water, and daily we're managing the water, for example, to keep these areas under sea level dry. On the other hand, we also have floods, and we have to produce drinking water. So it's basically daily water management in a delta area. On the other hand, when you look at the climate in Oman, there's the problem of scarcity of water. So a lot of people say to me, what is this? That the problems in Oman are probably completely different. And the funny thing is, when you zoom in, you look at the problems in a wet country, in a dry country, then almost all the problems are the same. You have floods, we have floods. You want to produce drinking water, we want to produce drinking water. You have soil and groundwater contamination. You are all types of industrial activities. We have the same. So we have a lot in common. And I think the challenge of the chair is actually to bridge the gap between these two worlds, because the climate is different, but the problems we encounter are the same. So that is, I think, one of the nice things of the chair. Currently, I have a lot of communication with Oman. I've been here several times. Students of me, of our group, come here frequently. We work intensively with Sultan Qaboos University, which is a true pleasure, and this all in relation to the chair, and that is, I think, a very special thing. Actually, November 6th, my next student is coming, and he's going to participate in the so-called SOHAR Water Availability Management Project. So I try now to bridge the gap between the start of the presentation and where we are now. What do you think? Ah, okay. Thank you very, very much. And this works also?
We need to move it for the slides.
Oh, yeah, okay, that's good. So, I said something about the history of the Sultan Qaboos Academic Chair, and this is a very famous picture. And here you see the raft of the Medusa. The Medusa was a vessel, and the vessel had a big problem, and at some point it was sinking. And almost 150 people could save themselves by building a very simple raft, and they were on the raft. And basically the vessel, the Medusa, went down, and in the morning when the sun came up, the people looked around, and they were extremely happy that they were saved, because they were still alive, and the boat was gone, and they were on this raft. Now, after a few days, they found out that there was water everywhere, but they couldn't drink any drop. It was impossible because the water was salty, and people that tried to drink the salty water, they got ill, very ill, and some of them even died because the kidneys can't handle high salt concentrations. So I think this is a beautiful example of where you have an enemy and a friend, and both are present. So the friend is the fact that you float on the raft on the salty water, and the enemy is that you can't drink the water. There's also a beautiful poem that says, "Water, water everywhere, nor any drop to drink." So if we continue, then I would like to take you to this table. So I'm dealing with quantitative water management. Now here are numbers, and I like numbers, and I like mathematics. So here we go. This is a very simple table. The first column is the reservoir of water on Earth, so oceans, ice, the percentage of all water on the Earth, and the percentage of fresh water in it. Now, it's very easy to understand. So the first line says ocean, almost 97% of water is in the oceans, and 0% of the water in the oceans is fresh water. If you look at ice and snow, it's 2%, but 70% of all fresh water is actually in ice and snow. So that's a huge number. And if you look at groundwater, and as you might know, groundwater is extremely important for drinking water supply, production of drinking water. And then you see that the fresh water, or the groundwater, is less than 1% of all water on Earth. And actually 30% of all fresh water is in the groundwater. So it's actually a very small amount, and we heavily rely on it. So groundwater is actually something very important. Now, if you look at surface water, then when you see a mighty river or a big lake, you might think that there's a lot of fresh water in there. But actually, if you look at the numbers, I can't even pronounce these numbers. So small are they. So this is an idea of importance of fresh water and groundwater and the availability. Now, I did this a while ago, and if you Google blue gold, then you will find 123 million hits. So that's unbelievable. And I think that is an extremely bad metaphor, because fresh water is transparent, and it's only blue when it's in a bottle, okay? And the next thing is that people can survive without gold, blue gold, but not without water. So a normal human being can survive 3 or 4 days without water and almost 50 days without food. So it's a bad metaphor. And at some point when I was offered the chair, I was looking at, well, what is Oman, what is the history of Oman? And then I found a beautiful quote of His Majesty, and he said, and this is really what I like, water, it's a natural wealth. And that is, I think, a much better metaphor than the blue gold. Now let's move on. So I intend to give you an idea of what water management actually is, and let's look at coastal regions. At Sultan Qaboos University, at this very moment, there is a conference on coastal regions, so it's a coincidence. Now, water facts. So 2/3 of, for example, all the drinking water in my country comes from groundwater. And it has a big advantage, because groundwater is of very good quality, and it's extremely easy to produce. You make a hole in the ground, put a pipe in it, a filter, a pump, and there you are. You can produce groundwater. And if you want, you can also easily purify it. So get rid of excess iron, for example, chalk, because otherwise your washing machine has a problem after a few weeks. And that is groundwater. Now, there are 2 types of groundwater, how to produce it. You can do this from the shallow subsurface, so let's say in the first 100 meters, we call this the shallow subsurface, and from the deep subsurface. Now, the deep subsurface is when you're in the range of 100 meters and more. It's in general very old water, geological water, and it has a disadvantage. There's a very slow recharge. So it's whenever you use it, you could say you're mining it, and you can compare that to oil production. Now, in the shallow aquifers in coastal regions, in my country, for example, there's a lot of recharge because we have rain. So that's actually a big advantage. And there's one important disadvantage, and that's seawater intrusion. Now, of course, the groundwater is in the subsurface, and the subsurface consists of a porous medium, sand, for example, or fractured rock, and in the void space, the pore space, is the groundwater available. It's fully saturated over there. Now, if I want to look, if I want to look at a typical coastal situation, then you see here a cross-section of a coast. At the right-hand side we see sea. The sea is salty water. The left-hand side we see a dune, for example, consisting of sand, and we have rain. So typical Dutch situation, by the way. The rain recharges the fresh water, and what we have basically is a big body of fresh water which is available for drinking water production. And that's what we do. We do it in Holland, we do it also in Oman. It's very tempting to use this beautiful fresh water. Now, so what you do, you construct a pump, and so these are details. You construct a pump, and you start producing the fresh groundwater. Now, two things will happen. First of all, we have an interface between salt water and fresh water, and the interface starts to move. It starts to move land inwards, so that is the seawater intrusion. The second thing that happens is that the interface will come up. We call this upconing. So if you are not doing this in the right way, after a while you'll produce salty water, and that's not what you want, because you destroy your well and also your local environment. So these are two problems that arise. And can understand that we might have to come up with some scheme to manage this. And so how can we produce fresh water such that we do not destroy our well and we're pumping salt water? And of course this is management. So we have to manage this water in order to have a continuous, sustainable groundwater supply. And how can we manage this? And then I'll say, well, we're going to do this. Yeah? This is actually what we're going to use. So you might think, what is this? But these are mathematical equations that represent the physics and the flow and the hydrology of the problem we've been talking about. So if we get some boundary conditions and initial conditions, we can solve this. So mathematics, quantitative issues are very important. And by using these abstract equations in a computer model, we can predict basically what this system is going to do. And that is part of water management. We want to quantify processes and want to see what they will mean for us in the future. So mathematics is extremely important. Now, not only mathematics, of course. We have a highly inter- or multidisciplinary issue here, this water management. So it's a combination, and I really want to stress that, of physics, the flow of fluids, geochemistry, chemistry itself, think of the contaminants, but also of natural geochemical processes, ecology, so that includes also biology, microbiology, I'll come back to that later. Mathematics, I already said, so the mathematics lead to a model, we need computers, so numerical methods and also geographical information systems. And I think this is essential, that all these aspects are there. So very inter- or multidisciplinary. Is it working? Yeah, okay. Very good, thank you. So let's move on. Now, the Netherlands, we talked about this. So these are two pictures of my country. The left-hand side, if we would remove all the dikes, and then you see the country is almost gone. Basically, I live somewhere over here, and my house is almost 7 meters below sea level, and I feel completely safe. So I don't have to worry because we have a very nice water management system. Now, if you put all the dikes there as they are now, then you have the Netherlands, the picture of the Netherlands like this. So this is really a huge operation to manage basically and maintain this system. Now, if you look at the history, do this very briefly, then in 1100, 1200, people started to dewater peat because they wanted to use peat as a fuel to heat their houses and to cook. And the consequence was that the peat is very compressible, so there was subsidence. The ground level went down. So they said, okay, maybe we better put dikes around these areas and keep the water out. So that's what they did, and something completely new emerged, and that is so-called water boards. They were in charge, basically, as a social unit, to manage this water system. So they had to maintain the dikes, etc. And we call this polders, and we created something completely new, and that's living below sea level, without being afraid. Now then, all of a sudden we had this terrible flood, thousands of people died, and then the Netherlands said, okay, this was not very efficient, we have to do this really countrywide, and we have to organize this better. And that is the nationwide water management system. Okay, so the lowest point, this typical picture of the Netherlands. Our highest mountain is 300 meters high. So that's, and we only have one, and the rest is like this. So it's completely flat, and it's really man-made, you could say. I mentioned floods. Unfortunately, in 1953, there was a huge flood in the south of the Netherlands, so the southern part, and this meant many casualties, and the government said, okay, this is terrible, we have to avoid this. So we have to come up with a flood preparedness plan such that the whole of the Netherlands will be protected in the coming 100 to 2,000 years. And of course that was a major operation. Well, Muscat also suffers from floods. This was of course a very recent one, and I think still reconstruction of damaged issues are going on. Now, what did we do? So here you see the southern part, coastal part of the Netherlands. They're all islands. And so what do islands mean? That you have a very long coastal line. And the main issue of the plan to avoid floods was to make the coastal line as short as possible. So what they did, they shut off all these estuary over here, over here, over here, and created dams everywhere. And dams to protect the country against these floods. And for some reason, they said, okay, some of these dams have to be semi-permeable because there are environmental concerns. And one of the dams is now indeed open all the time for the sea, but if a storm is coming, then they really close off this dam. It was an extremely expensive operation, and you see all kinds of structures that prevent the Netherlands from being flooded. Also in Muscat, many issues are there to prevent the flood. Okay, but the emphasis in the Netherlands was really on flood protection and nothing else. And some of the environmental people were complaining, and that's why they made this one dam semi-permeable. But the main emphasis was on engineering coastal constructions. And actually we really regret this now. To be honest, there was a huge ecological impact because you turned all kinds of estuary from saltwater to freshwater and vice versa. And there were many undesired environmental side effects. So at the moment they are basically reversing this process, and you could say that this type of human interference in the hydrological cycle is maybe sometimes not a good idea. And whenever you do this, you have to do this very carefully. And I think the concept of building with nature, that nature is really part of your plan, that it's not only engineering and concrete and things like that, but that you take the whole water management into account, so ecological effect, environmental effect, etc., is extremely important. And I think this is an example where we did a good job in the flood protection, but with respect to the environmental issues, it is not really a disaster, but it's not good. And we have to avoid that in future projects. Now, there's another example I would like to give, and that is the famous Three Gorges Dam in China. It is probably the biggest dam on Earth. It is a huge, unbelievable construction, and here you see some pictures, and basically it is a hydropower dam. Okay, well, so to build this dam, more than 1.2 million people had to move. They had to leave their houses because of the construction of this thing. It gave rise to landslides, erosion, so soil is washed away from mountain slopes. Downstream drought, that's also not what they expected really. The water quality seriously deteriorated, so the water is contaminated, you can't use it anymore. There's subsidence, and there's one big issue now, and there is reservoir-induced seismicity, probably. So that means that the huge amount of water behind this dam is so heavy that it might activate faults in the earth that are below this water mass. And also this dam is already in a seismic active area. So that is reservoir-induced seismicity gives rise to earthquakes. So I already said this. And now, not too long ago, 700 kilometers from the Three Gorges Dam, there was the epicenter of a huge earthquake. And some scientists think that this has already something to do with the amount of water and the mass of the amount of water which is there. However, it's really very hard to prove. Now imagine what will happen if, due to a normal earthquake, this construction would fail. Then millions of people are in danger and probably will die. So that could have a tremendous impact. So here you see that maybe the geophysics of this water management project is underestimated. I don't know, but it could be. And also the environmental impact. And I found a quote, and this is really serious, where somebody from China, a quote from the China State Council said, "We simply cannot sacrifice the environment in exchange for temporary economic gain." So they start to realize that maybe this whole thing could have been done better in an integral way. Let me give you another example. Well, everybody here has heard of the River Jordan. It's really an important river. It was once a mighty river. There are books, poems that state that it was a mighty river. And unfortunately, people started to manage the water of River Jordan. And they wanted to use it because it's fresh water, so why not use it for water supply? So what they did, Israel, for example, which is located over here, of course, started to make this, the big water carrier, national water carrier project. It is responsible for the distribution of almost all fresh water in Israel. So that's a huge thing. So they tapped basically, so here in the northern part, the water from River Jordan. What they also did in Jordan, they diverted the river Yarnouk, which was was putting water into the River Jordan. So also that water disappeared because they used it for other purposes. And then Syria said, okay, they created fresh water reservoirs to store the water of the Yarnouk River. So everybody took water. And what happened is really, you can't believe this, that this is what is left of River Jordan. And this is not a joke, I'm serious. This is a picture, of course not at the beginning of the River Jordan, but this is what it is. And what you see is a small stream, only 2% of the original water is still in this stream. And the water is heavily polluted because people put sewage, dispose sewage in it, and there are chemicals, it's a high salt quality, so it's gone, this river. Now, it has another consequence, that it feeds the Dead Sea. And this is a picture of the Dead Sea, and the Dead Sea is, of course, a very special environment. So there's no more water coming into the Dead Sea. So this Dead Sea is basically dying at the moment because of lack of water. So the unique environmental conditions of the Dead Sea are changing due to water management. And Of course, it's not a good idea. Now, fortunately, environmental scientists, the Friends of the Earth Middle East, these are environmental scientists, they say, okay, we've gone too far. And together with Jordan, Syria, I think Egypt is involved, and Israel, we're going to revitalize, rehabilitate the River Jordan. And I've met these people, they're very enthusiastic about this, and this is a science-based operation. It's nothing to do with politics, only the science, and to bring back water in River Jordan without saying you have to stop all with your activities, because that is the simple solution. But they come up with a very nice solution. I can't go into detail here. And actually they use the example of the rehabilitation of River Rhine in Europe that was heavily contaminated with industrial salts. So in the Netherlands we got all this salt coming from Germany, etc. And we, together with all the governments and with the environmental scientists, we rehabilitated this water. And there's even salmon swimming in the Rhine. And it's not smoked salmon, it's fresh salmon. Okay, one more. Yeah, I come up with all sad stories. I can't help it, but maybe I can end with a positive thing. There's something, if you want to produce drinking water, of course you can rely on surface water. In Bangladesh, they have a lot of surface water. They have floods every year, and it's really a delta area, so you can compare it to the Netherlands, although the climate, of course, is really different. The problem is, of course, that this water, surface water, is used for all kinds of purposes, and unfortunately there's a lot of biological contamination. So that means that if you drink this water, you get seriously ill. So not just a little bit, but you could, and children die of this. So this was terrible. So in the 70s, there's the bacteria and contaminants responsible for that. So in the 70s, there was a solution for this, and the UNICEF, amongst others, they said, okay, what we have to do is not use the surface water, which is of bad quality, but we have to use the groundwater. Here we are again with groundwater, because it has a beautiful quality. And well, it seems to be a very good idea. So what you do is make shallow tube wells, very simple ones. People can operate this without electricity or whatsoever, with mechanical pumps, for example. And you can produce this groundwater. It's and they tested, of course, they tested the groundwater on all kinds of substances, the salt content, the heavy metals, organic matter, you name it, they did it. Okay, according to the normal standard drinking water procedures we have in the Netherlands or in the US or whatever, and it was no problem. Okay, however, and now. I don't like to show these pictures, but just to give you an impression, this is what happened. So after a few years, people started to get really very strange marks on their skin. I'll skip the picture as soon as possible. And people died, got very ill, and millions of people were affected by this. And nobody knew what was going on. And then they found out that there was one substance, a chemical substance called arsenic. And arsenic is a poison, okay? And arsenic is present in the groundwater, the shallow groundwater of Bangladesh, almost everywhere. Here you see a picture. The purple indicates the highest probability of the occurrence of arsenic. So basically it's everywhere. And there were hundreds of thousands of these shallow tube wells installed. There were millions spent for this operation, all with good intentions, and it turned out to be mass poisoning, unwanted, undesired mass poisoning of people. And that is, of course, a big problem. Now, do you think that in 1970 there was not one geochemist that was not aware of arsenic in the subsurface? This is known since many centuries, or let's say during the last century at least. And these specialists know this because arsenic is a naturally occurring contaminant, you could say. So it's not industry that did this, nature did this. However, the geochemists were not involved because water management is something that hydrologists do and not chemists. And the hydrologists have their standards for analysis of groundwater, and arsenic is not on the list, so they don't have to do that. So here you see that once again, one link is missing, and that is giving really a disaster. And so we try to come up with a solution. Now, the solution in Bangladesh is very simple. They tested all the wells, the shallow tube wells, and as you saw on the picture of the country, not everywhere you have high concentration. So they said, let's do it this way. We analyze the water on arsenic. If it's below the limit, and the limit in Bangladesh is 4 times higher than the international limit for arsenic. I don't understand this, but anyway, if it's below that limit, we paint it green. If it's above the limit, we paint it red. Now so it's very simple. So if you see a red well, don't drink it, okay? So I had a student, a girl, she went to Bangladesh because we are involved in trying to come up for a solution with this. We think that we could utilize the deep groundwater, which is not really in contact with the shallow groundwater, and this is of good quality. And she went there to take samples of the deep wells. And she did, but she said, I see all these green wells, the shallow ones, and the red wells. So she took also samples of 20 of the green and 20 of the red wells. We analyzed this, and the result was shocking because there's no significant difference in arsenic content between the green and the red wells. So it's terrible. Now what we say, I would say paint it black, okay, instead of red. That is maybe a better color for, and don't drink it. So here, we saw this picture again, but I want to emphasize that if you involve all these disciplines, so water management is not monodiscipline. We can't sit just in our office with the door closed, but we have to be in contact with geochemists, with ecologists, with microbiologists, etc. We all have to involve them, and maybe even the government should emphasize in big projects that independent scientists are also involved, just to look at what is going on and not just rely on engineering. Engineering is a good thing, but maybe this is a better idea. So, oh really? Now, so let me speed up in that case. So water resources management, there are many things to produce fresh water. One of them is desalination. Very simple principle, but this needs a lot of energy, fossil energy, and as we all know, in the future, fossil energy will be scarce and the price will go up. So the price of this water will definitely also rise, and so you can't use it for agricultural or other purposes. Another big issue for water resources is artificial recharge. I showed you the picture with the rain, and of course we have rain in the Netherlands. But in Oman you have to do something different with recharge dams. Collect the water in mountain areas, for example, and give it time to infiltrate in the coastal areas. Infiltration of maybe treated wastewater. Sultan Qaboos University is also looking at that. Pre-treated water that you put into the subsurface for drinking water purposes or irrigation purposes. Vertical infiltration systems. This is one of the systems I really love. It's thousands of years old and it's still functioning, and it plays still a role, an important role in freshwater distribution, in particular in the rural areas. So this is also part of the picture. Another thing is, of course, irrigation optimization. Almost all fresh water in Oman that is produced from natural resources is used for irrigation. That's very inefficient. So we can win a lot of this. And I think my colleague, the next speaker, will talk about this type of irrigation optimization. So if you ask me, what is the future of fresh water in semi-arid regions, then it will be the sum of all kinds of these methods. So desalination, the aflach will play a role, recharge dams, whatever. So if you ask me, is the glass half full or half empty, then I show you this picture. And you can read from the picture what I think. I think it is half full because there's still water coming in. So I'm rather optimistic, but you can only be optimistic if you join forces and look at water management as an integral, multidisciplinary science. And I think that is the basic message that I would like to transmit here. So integrated water management, and there's not a single solution to water problems, but of course it is the sum of sustainable problems. So I have one more small thing that I would like to add. Yes, thank you very much. I give you one exciting example. So this was a general story, and of course I am much more involved in say, the real scientific issues. And one thing that happened is that I went on a mission, I do this very quickly, to Yunnan, and Yunnan is a province in China, and it was very dry. This is the Prime Minister of China, and he's visiting Yunnan, and this was the picture. So it's a very dry province, and it has occasionally very intensive rain. So 4 times more rain than we receive in the Netherlands in a full year, they get in a few months. So that is really very attractive. But all this water disappears in the subsurface because you have fractured rocks, so that is the bottom, you have soil on top of it, and the water comes on the soil and it drips through the soil and it goes through the fractures in the rock and it disappears. You can't use it for, so there's no groundwater table. You can't produce groundwater. So it would be a very nice idea if we could seal these fractures, and then of course the water can't go into the rock anymore. So in the soil we get a groundwater table. If we can do this on a large scale, we can make a huge underground water reservoir and to store water that is available in the wet period and use it in the dry period, because in Yunnan for half a year there was no rain. And the idea was the following, and I speed up. So there was this mission, and here you see a picture of the typical system. And so here we have soil, and underneath is rock with all kinds of fractures. You see this? All kinds of fractures, and that's the idea. Now, there's a karst region. And the idea to seal these fractures is with bacteria. In the soil we have naturally occurring bacteria. Everywhere on the world they are available, different types of course. But you can activate these bacteria by one simple thing, and that's by feeding them. Simply give them something to eat. And what you give them to eat is very simple. It's not a contaminant, it's not harmful for environment. It is very simple. So, and when it rains, you can add this food to the water. It will go down and basically activate the bacteria to produce bioslime. Now, so there we go. And I'll give you an example. We can go even from loose sand, yeah, to sandstone using bacteria. Now, I think that's very exciting. We did all kinds of experiments, and we call this biosealing. So the idea is that we're going to add to the surface food, then the rain will take it into the soil, go to the fractures, and the fractures will be clogged, not only by the bacteria, but also by small particles. Now, the conclusions. So I'll finalize. Multidisciplinary water management is desired to avoid highly undesired side effects. I think the 4 examples, and there are many more, I'm sorry to say, that show undesired side effects. So we're really sorry that we started the whole operation. Building with nature, I think, should be central in all water management projects. So use the capacity of nature. Don't destroy it, but work together with nature to establish your goals. Future water management is the sum of new and existing solutions. Of course, we still are looking for new solutions, but we also have to respect the solutions we already have. It will be all in the equation. And there are many exciting challenges. And I gave you one example, and there are many more. But the microbes I really like. Of course, we work together with microbiologists and chemists, etc., to achieve this goal. And I think that is a beautiful example. So this is where my story ends. Fresh water everywhere. I hope enough for all. Thank you very much.
بروفيسور رود، ونحن يمكن من خلال المحاضرة، يمكن أنا غير متخصصة في مواضيع المطروحة في محاضرة البروفيسور، لكن نعتقد أنه ما زال التفاؤل قائم بأنه ما زال نصف الكأس فارغ، وهذا دليل على أنه الدراسات والبحوث لا تقودنا إلى ما كان موجود قبل من توقعات أو من دراسات وتجارب جعلت البيئة تعاني ما تعانيه اليوم، لكن الدراسات القادمة المستقبلية سوف تخفف من حدة النتائج السلبية على البيئة. لكون البروفيسور رود بدأ متأخراً فمنحناه عدد يعني من الدقائق الإضافية، لكن نتمنى من الحضور وخاصة من الطلبة المتخصصين في مجال علوم الأرض وعلوم المياه أن تكون الأسئلة يعني دقيقة وواضحة دون مداخلات ودون شروح ودون عرض آخر للمحاضرة بطريقة أو بأخرى. نفتح الباب الآن ونحاول تقليص الأسئلة فقط كسباً للوقت، وننتقل إلى المحاضر الذي يلي بروفيسور رود. تفضل حضور. You need to put the translator.
So the engineering today, the electrical engineering is not helping me. Now it works? Okay.
وين ما أشوف حد.
So there we go.
تفضل. نعم.
Yes, please.
Yes, go ahead. Yes. المايك إذا تسمحوا.
Good morning. I'm Professor Sharma from Sur College of Applied Sciences. I come from Rajasthan state of India.
No,
The
it's in English.
groundwater in my place is very salty and contaminated. Desalination is a very expensive process. The government cannot afford to do that. There is no rains also. It's a desert area. What kind of solution you would like to suggest for this?
There is, sorry, I missed the last sentence. I'm very sorry.
The last sentence is that there is no rains. It's a desert. So no rains, you cannot harvest water. The groundwater available is contaminated and salty.
Yeah.
Desalination is a very expensive process for a country like India.
Yeah.
Now, what kind of solution you would like to suggest for this problem? That's my question.
Well, of course, when there's absolutely no water available, then we really have a problem. I mean, that is obvious, and I would love to state here that I have the solution, but unfortunately that is not the case. With respect to desalination, of course, people are looking to improve the technique, and there are classical techniques. Of course, water technology is not my issue, but I know some about it. So the classical desalination is based on reverse osmosis, and of course you have to build up a pressure to press this fresh water through a membrane. And of course there is a thermodynamic limit that tells you need this amount of energy, and then you can compute very easily how much money is involved. And of course when the fossil energy price is going up, your water price is also going up. On the other hand, they're looking at all kinds of innovative techniques at the moment to, for example, get water out of air. There's always some moisture in the air, so how can you utilize that, for example? The desalination techniques, I know in our country they're using now all kinds of electrical effects to basically, that are much cheaper apparently than the classical techniques. So there is improvement, but I always compare this to say solar energy. So solar energy cells are available for decades, and when you look at it, it's very attractive to put research in this, but the advancements are extremely slow. And so the optimal solar cell still has to be designed. The material you need is expensive. It has a very low efficiency. So the amount of energy that you get from the cell is not a lot. And I think that is also the case with the water issue, that there are advancements, but it's slow, and it's also a very difficult issue. And I can tell you, whenever there's no water at all, then yeah, of course, then it's a problem. But if there's some water available, then I think new techniques might help. And they will all be a part in this picture, a very small part maybe, or a larger part. You can compare this to the energy problem. And so now we have still a lot of fossil energy. If the fossil energy is gone, we have to use the whole spectrum. So that means solar energy, wind energy, maybe nuclear energy, etc., etc. And they will all be in this picture to basically satisfy our needs with respect to energy. And the same is true for water. I can't help that. Yes, please.
تفضل. ظهرت الأسئلة الآن.
My colleague.
I have just 3 questions. First one, if I understand you properly, you have suggested that instead of big dams, we should have smaller dams in order to have a better geology, right?
Shall I immediately react?
You
Otherwise, I
just
forget
gave
your
the
next
example of China, a bigger
Yeah.
dam for producing electricity, and
It's
that had earthquake and other effects.
Yeah.
So if we could have smaller dams instead of one big dam, that probably I get out of your talk that could be a suggestion.
Now, well, let me put it this way. So, of course, you could say, well, maybe if we replace this dam by 5 smaller ones, we can achieve the same. So that might be the solution. But what I would like to stress is that once you start with such a huge investment and such a huge project, you should include all these disciplines that are there, and maybe use independent scientists. Just make a committee that is also looking at this. And sometimes people simply forget things, and they don't do that intentionally. Sometimes the money issue is, of course, also there. But the Bangladesh thing was this completely not anticipated. And of course, whenever you would have a geochemist on the team, he would immediately have said, come on, you can't do this. And that is what not happened. So if you do the China project, then here I think involvement of geophysicists would have helped. And maybe they would have made the same construction but slightly different, such that, at a different location, such that they can diminish the risks of earthquakes, for example.
The second important point is that we should also conserve water. Conservation of energy, for example, is important. In the same way, conservation of water should be looked into, and probably that's a very important issue. And then recycling of water, for example, we are wasting a lot of water, and we could recycle and reuse that water time and again, as it is being done in advanced countries. Probably we could do that in the developing countries right from now, rather than waiting for future.
Yeah, that's, I think the recycling is a very important issue. I work with Sultan Qaboos University. Students of me look at this. So wastewater, which is purified up to a certain level. And then you see again this concept of building with nature, because the soil can purify water. Of course, it can't take heavy metals from the water or other harmful substances, but it has a self-purification issue, and you can utilize that. And that is basically what we do in the Netherlands too. So we infiltrate, because even the rain in the Netherlands is not enough. So for the city of Amsterdam, we use the dune water, so from the coastal region. But if we need so much fresh water from that dunes that we are mining the shallow fresh water. So we don't want that. So what we started to do is to infiltrate surface water from a river, and we pre-treat that such that the harmful contaminants are gone, and then we simply infiltrate it into the subsurface. And then we let it pass through the subsurface like normal groundwater for at least 60 days. And that implies that, for example, viruses are all dead, they all die, and all kinds of microbes that are also not wanted. They are basically pure, taken out of the water by the soil. So nature has a cleaning capacity, and we use this. And then we pump the water again, and we send it to Amsterdam, and they have beautiful drinking water. And that's the way we have a sustainable cycle. So the combination of the rain and the artificial recharge. Now, of course, you can also use wastewater, not heavily polluted, of course, but wastewater from factories, manufacturing plants, that you purify a little bit and then put in the ground, in the subsurface for storage, recharge of fresh water. And of course you achieve two things. First of all, you're storing fresh water, so your volume will increase. And on the other hand, you're pushing back the salt water to the sea. Because whenever there's fresh water coming in, salt water has to go out. So you achieve two goals, and I think that's
we
very
have two more
interesting
questions,
also.
Professor. Two more questions. Dr. Salima.
Yes, please.
تفضل.
Thank you very much. Thank you for a very interesting lecture. I think you managed to educate many of us who are not in the field of water. But I'll go to the question directly. My question is, what do you think are the main challenges that are facing Oman in terms of suitability of water for drinking and agriculture, and etc., and also for preventing the country from the disastrous effect of water like what we have seen a couple of years ago? That's my question. What are the main challenges that are facing us in terms of availability, suitability of water, and in terms of preventing or the country from the disastrous effect of water?
So basically these are two questions. So let me start with the last one. In response to floods, for example, that's what you mean in your last part of the question. In response to floods, you can do two things, basically. You can say, okay, I'm waiting for the next flood. And then, the flood is coming. Now, and then it destroys your bridges and roads. And you say, okay, we have to rebuild it. Now, we rebuild it. Maybe we make it a little bit stronger, that next time it won't be that bad. But then in 10 years, or 1 year, or 50 years, an even worse flood comes and destroys everything. And you can say, okay, well, so I start building again. But you can also say, and that is what we try to do in the Netherlands, not say successful, because since 1953 we never had problems with floods. We had floods, but no damage. And so then you can say, let's make a nationwide plan. So let's look at the situation. What is the situation in Sohar? What is the situation in Muscat? And what can we expect? And then you can basically predict, using mathematics and all the methods I showed, that, for example, you can defend yourself for a storm that occurs, say, in 1 in 1,000 years. So that's a huge storm, which we can't imagine, but you can make a plan that really provides that defense. So that is two types of reaction to floods. So one is just see what happens and rebuild and carry on with the daily life, or do a huge, also investment, and not only in money-wise, but also intellectual and engineering, etc., and prepare the country for the worst. And so that's a reaction. Now, with respect to the first part of your question, what are the challenges? Now, I think, and maybe you don't want to hear this, but I'm going to say it, that a lot can be gained in, for example, irrigation. It's really very simple, but irrigation uses a lot of fresh water, of the natural freshwater resources of Oman. So if you could reduce this volume by 50%, you have an enormous amount of fresh water available for other purposes. So maybe you could use this for drinking water production. So that means that the water that you lose, because irrigation, and my colleague is going to emphasize that, I think, is usually 80% of the water does not get to your crop. It evaporates and it runs off, and only 20% or 30%, but he's going to correct me, I hope, is only used. So if you can optimize that, and I think there is a lot to be gained, then that is a good idea. the recharge dams. So the operation of the recharge dams, very simple concept, probably everybody knows, but and in the mountains it rains, you have the flash floods, maybe only a few times a year, but that is really intensive rain, and there's a lot of water coming down the hill. And if you don't do anything, then most of it evaporates or runs off to the sea. So what you're doing is diluting the sea. That's not a good idea. So what you do, you build a big dam, and this water catches, this dam basically catches the water, and it gets time to infiltrate into the subsurface. So I'm recharging the fresh water in the coastal region. Now, even with these dams installed, you have a lot of problems. For example, the bottom of the dam reservoir is clogged, so the water can't infiltrate. If the water stays there under these temperatures for a while, then it gets contaminated and you can't use it anymore. So it's a bad situation. Or the flood is so severe that it runs over the dam and you lose it anyway. So improving, for example, the infiltration techniques in these dam regions is something to invest in. And of course, we're all hoping that some miracle will happen. And that you say, okay, there will be all of a sudden a new source of water. But with that respect, I'm quite pessimistic. But with respect to improving water availability in these regions, I'm really optimistic because we can still gain a lot. And these will all be small steps forward. I hope this answers your question.
السؤال الأخير، نعطي الأولوية للطلبة من المتخصصين أو ننتقل إلى صف اليسار؟ إذا ما لم يوجد طلبة من المتخصصين، طلبة، الأولوية للطلبة، أو نأتي إلى اليسار كأولوية ثانية. تفضلي الأخت نهلة، تفضلي. يعني صعوبة أخذ جميع الأسئلة مرة واحدة.
Thank you very much for your interesting paper. I just have one question. You mentioned that good water management is an interdisciplinary issue, and I agree very much with that. And then you mentioned 7 disciplines that we had to address in order to manage water efficiently. I was just thinking in practical terms, in the Netherlands, whenever you come to implement a major water-related project, do you have any policies or any methods to ensure that it will be managed in an interdisciplinary way? How can we achieve that in practical terms?
To be honest, the Ministry of Environmental Issues is also responsible for the water issues. So they were responsible for what we call the Delta Plan. Okay, so that was the flood protection program that was designed after the huge disaster in 1953. These people were, and I don't want to offend any engineer, but these people were engineers at that time, okay? So they were used to think in concrete and in water on one side and no water on the other side, and steel and constructions and things like that. And that was the start of this plan. And these were all engineers. Everybody had the title engineer. And it was not a big problem, of course, but so then this whole thing was implemented. First they made this plan, and then all these dikes were built and all these dams, and then after a while people started to see that the environment changed. So all kinds of animals disappeared, and when you change from salt water to fresh water, that has a huge ecological impact. And do we really want that? Also the polders, so the parts of the Netherlands that are below sea level, some of these polders, we really regret that we created them, because the environment changed such a lot that we are sorry, and we are going to reverse this. And people can't understand that in the Netherlands, first they built these polders, and then at some point the inside, the scientific inside changes, and then we say, okay, farmers, sorry, you have to move, because this land will be water again. how is it possible? But that is a change in thinking. So nature is our ally, and the ministry that was responsible for all this, all the engineers, slowly but surely also biologists were hired, you could say, and chemists and people from all kinds of disciplines, and they together came up with a completely new vision that, okay, the engineering thing is okay, and my opinion is that we can do a lot with engineering, almost everything, but you can't ignore all the other facts. And it's a very simple message, but this is reality. And we in the Netherlands, we all learned this by making mistakes, basically. And I think now this concept is very important. And it would be great if other countries would do the same. And yeah, I think it's a good concept. Does this answer your question?
Yeah, I was just...
ما في مداخلات الأخت نهلة.
Sorry, thank you. Sorry.
Yes.
Thank you very much. شكرا جزيلا Professor Royd for your محاضرتك القيمة طبعا تتداخل اللغات. نتمنى أن تكون الفائدة عمت الجميع في الاستفادة من كيفية إيجاد حلول للتخفيف من مشاكل المياه خاصة في السلطنة بما يخص من ملوحة المياه وجفاف المياه. ونشكر مرة أخرى بروفيسور على محاضرة هذه القيمة. Thank you very much.
Thank you very much.
Wish you all the best.
It was a real pleasure. Thank you very much.
ضيوفنا الكرام، نترككم الآن مع الورقة الثانية بعنوان إمكانات إنتاج علف الشعير باستخدام نظام الزراعة المائية في دول مجلس التعاون الخليجي اعتمادا على مياه الصرف الصحي المعالجة. يلقيها الدكتور أسد الله العجمي، الأستاذ السابق لكرسي صاحب الجلالة السلطان قابوس بن سعيد المعظم للاستزراع الصحراوي جامعة الخليج العربي البحرين. متابعة مفيدة نرجوها لكم.
طبعا الدكتور أسد الله أحمد محمد العجمي، أستاذ كرسي السلطان قابوس للزراعة الصحراوية سابقا بجامعة الخليج العربي بمملكة البحرين، يعمل حاليا بتقييم وتطوير البرامج الأكاديمية بوزارة التعليم العالي، وقد قام بالعديد من البحوث والدراسات المرتبطة بمجال الزراعة الصحراوية واستخدامات المياه في إنتاج علف الشعير، وقد حصل على جائزة من منظمة الغذاء والزراعة التابعة للأمم المتحدة للإنجاز المتميز في المهمة الاستشارية المتعلقة باستخدامات المياه وتنمية المناطق الريفية. ورقة الدكتور أسد الله العجمي بعنوان مثل ما ذكر مقدم الورقة: إمكانية إنتاج علف الشعير بنظام الزراعة المائية في دول مجلس التعاون الخليجي باستخدام مياه الصرف الصحية المعالجة بالمستوى الثالث. تفضل الدكتور. شكرا.
السلام عليكم. شكرا معالي الوزيرة رئيسة الجلسة. في الواقع المحاضرة حتكون من 3 أجزاء. الجزء اللي قدمني فيها الورقة حتكون الجزء الأخير من الورقة. حاخذ على حسب الوقت المتاح جزء للتعريف بجامعة الخليج العربي، والجزء الآخر بالكرسي الأكاديمي، والمركز اللي انبثق عن الكرسي الأكاديمي، ثم ما يتبقى من الوقت إن شاء الله نتكلم بشكل سريع. الورقة حتكون منشورة في المداولات الندوة هذه، فما أتعرض لكل التفاصيل إنما لبعض النتائج بشكل سريع. جامعة الخليج العربي طبعا موقعها في مملكة البحرين، هي جامعة أنشئت أصلا لتمثل يعني رمزية للوحدة الخليجية، وجت بالتزامن مع تشكيل الوحدة السياسية اللي معروفة بمجلس التعاون لدول الخليج العربية. فكان إنشاء هذه الجامعة من قبل الدول الأعضاء في المجلس هو عبارة عن تشكيل أكاديمي ليمثل الوحدة الخليجية في الجانب التعليمي. وأنا وضعت على السلايد الأول اللي هو العنوان الإلكتروني لموقع الجامعة. إذن في عام 79 تم توقيع الاتفاقية النهائية لإنشاء الجامعة، والجامعة هي هيئة إقليمية غير سياسية ذات شخصية اعتبارية. هدف الجامعة هو الإسهام في كل ما من شأنه تطوير التربية والتعليم العالي والبحث العلمي والتنمية الشاملة في دول مجلس التعاون الخليجي. طبعا هناك بعد سياسي في تشكيل الجامعة مثل ما ذكرنا، ومنها هي دعم الولاء والوطنية للمنطقة وتراثها العربي والإسلامي بالنسبة للدارسين بالجامعة، وهو طبعا المكان اللي يلتقوا فيه أبناء مجلس التعاون تحت سقف واحد بحيث يتم تهيئتهم تربويا وأكاديميا. طبعا هناك أيضا هدف تنموي لتوحيد جهود دول مجلس التعاون في مجال الاستثمار في التنمية البشرية، وأيضا للجامعة مساهمة في النهضة الثقافية العربية وتدعيم القيم الإسلامية. طبعا وضعت آليات لتنفيذ هذه الأهداف، سوف لن أدخل بالتفاصيل بسبب ضيق الوقت، لكن أبي أشير أنه البحوث تشكل قاعدة رئيسية من أعمال الجامعة، فهي تقوم بالدراسات التنموية لتساهم في الوصول إلى حلول علمية وعملية لمشاكل المنطقة. هذا بشكل سريع هو الجامعة. عندنا كليتين رئيسية في الجامعة، كلية للطب والعلوم الطبية، وعندنا جامعة أخرى اللي هي عندنا كلية ثانية هي كلية الدراسات العليا، وهذه طبعا تشكيلة الجامعة. الجامعة طبعا تدار من قبل دول مجلس التعاون، فهناك مجلس أمناء يمثل في كل دولة من دول مجلس التعاون بممثل. هذول مجموعة الرؤساء اللي تناوبوا، طبعا هناك تناوب برئاسة الجامعة. حاليا الدكتور خالد العوهلي من المملكة العربية السعودية اللي يشرفنا في هذا اللقاء اليوم هنا في القاعة هذه، ونامل إن شاء الله الرئيس القادم إن شاء الله من سلطنة عمان، دور السلطنة إن شاء الله في الرئاسة القادمة إن شاء الله. الجامعة دائما تهدف إلى ما يسمى بالتمويل الذاتي. حاليا التمويل الذاتي 60%، وهناك هدف لإيصاله ل 70% وهكذا. إذن هناك 40% تأتي من مساهمات الدول الأعضاء. التمويل الذاتي طبعا هناك عدة قنوات للتمويل الذاتي للجامعة: الدراسات، الدورات، الوقفيات، التبرعات، وأيضا طبعا رسوم الطلبة تساهم في تمويل الجامعة. أبي أشير لشيء مهم، أنه الجامعة تحتضن كراسي أكاديمية لكافة قادة دول مجلس التعاون الخليجي، وهذا اللي يميز جامعة الخليج العربي عن كل الجامعات الأخرى. فالجامعة تستضيف كرسي جلالة سلطان قابوس بن سعيد المعظم للاستزراع الصحراوي، وهناك مجالات أخرى لقادة دول مجلس التعاون الخليجي. إذن هناك كليتين، كلية للطب والعلوم الطبية وكلية للدراسات العليا. كلية الدراسات العليا فيها جزئين، فيها جزء متعلق بالدراسات التربوية، والجزء الآخر اللي هي الدراسات التقنية. وعندنا هناك معاهد مثل المعهد الفرنسي العربي للدراسات الإدارية والمالية، وحاليا أيضا أنشئ معهد للإدارة المتكاملة للموارد المائية في منطقة الشرق الأوسط. الجامعة أيضا تتعاون مع جامعات أخرى في مجال التدريس، الإشراف المشترك، الامتحان مثلا، والدراسات التعاقدية وغيرها. وهذه مجموعة من الجهات اللي تتعاون معها الجامعة، ومنها جامعة السلطان قابوس. النشر العلمي شيء مهم، وعندنا احنا مجلة في جامعة الخليج العربي تعنى بالبحوث العلمية، اسمها مجلة الخليج العربي للبحوث العلمية، وهي مفهرسة في 21 خدمة فهرسية عالمية. طيب، هذه بس فكرة عامة عن الجامعة. الحين نتكلم عن الكرسي الأكاديمي اللي جلالة السلطان قابوس بن سعيد المعظم للاستزراع الصحراوي، واللي انبثق عنه ما نسميه بمركز السلطان قابوس لتقنيات الزراعة المتطورة وبدون تربة. المركز هو عبارة عن، إذا نسميه، هو الأداة التنفيذية لأنشطة الكرسي الأكاديمي. يعني المركز هو الجهة أو الجهاز التنفيذي للأنشطة الخاصة بالكرسي الأكاديمي، فهم يعني تقريبا شيء واحد. لما نتكلم عن أنشطة الكرسي نتكلم عن مركز السلطان قابوس لتقنيات الزراعة بدون تربة، وبعد شوي نتكلم ليش المحور هو تقنيات الزراعة المتطورة والزراعة بدون تربة. طبعا حتى نتكلم عن الموضوع ليش أنشئ المركز وحتى الكرسي في مجال الاستزراع الصحراوي، لابد من خلفية سريعة عن الموضوع. احنا عندنا طبعا مشكلة نضوب المياه وتدهور نوعيتها، والبروفيسور رود كان شوي متفائل أعتقد في المحاضرة فيما يتعلق بالكأس إذا كان نصف الممتلئ أو الفارغ. احنا عندنا في الخليج يعني حقيقة مشاكل المياه مشاكل وصلت حد خطير، على الرغم من أنه الوضع في السلطنة مقارنة بدول مجلس التعاون لا زال بخير. العجز المائي عندنا أعتقد بحدود 30% حاليا، في دول وصل عندها العجز المائي 70%. لكن بشكل عام هناك عجز مائي في السلطنة. وأيضا المشكلة الأخرى هو تدهور نوعية المياه، وبالذات في المناطق الساحلية المياه في تدهور مستمر بسبب كثرة السحب من المخزون الجوفي. عندنا طبعا المحدد الآخر للزراعة هو المناخ يجعل الموسم الزراعي محدود جدا بفترة ضيقة جدا، وهذا أيضا طبعا يعيق من الإنتاج الزراعي على مدار العام. بالإضافة المشكلة هذه عندنا مشكلة المناخ تترتب عليها تبخر عالي من النبات، فبالتالي يزيد من الاحتياجات المائية للمحاصيل. من جانب آخر عندنا محددات للتربة. مشكلة التربة طبعا الكل عارفها، الخصوبة ضعيفة، في عندنا قوة الاحتفاظ أو قدرة التربة للاحتفاظ بالرطوبة أيضا ضعيفة، فبالتالي هناك يعني استنزاف مستمر للمياه من التربة، ناهيك عن مشكلة ملوحة تملح التربة اللي أصبح ظاهرة يعني في الفترة الأخيرة. المنافسة الخارجية أيضا من تحديات الزراعة، لأنه في النهاية المستهلك يعني يبحث عن الأفضل والأرخص، فلما يكون تحرير التجارة فهنا تدخل موضوع المنافسة كتحدي من تحديات اللي تواجه الزراعة. أيضا من مشكلة أو تحديات الزراعة هو ضعف مساهمة القطاع الزراعي في الناتج القومي المحلي. يعني لما تطلب أي موازنة للقطاع يجب أن يكون مبرر بمساهمة القطاع في الناتج القومي المحلي، وهذا حاليا ليس بالمستوى المطلوب. حنتكلم شوي عن موضوع العمالة الوطنية وعملها في الزراعة، هذا أيضا تحدي كبير حنتعرض له بعد شوي بشيء من التفصيل. هذا يلخص استخدامات المياه في دول المجلس، وتلاحظوا أنه اللون الأحمر هو المياه اللي بتروح للزراعة، فبتلاحظوا أنه معظم المياه في دول مجلس التعاون أو الكثير منها، في عمان عندنا حوالي أكثر من 90% من المياه هي للزراعة. في دراسة كانت تعمل مقارنة بين العام 70 والعام